Hey guys, welcome to ANS Solver. Today we'll be doing the concept of double angle formulae and advanced usage of these identities. Okay, which is a subtopic in the chapter of trigonometry. Okay, so first let's do the basic double angle formulae. Okay, so there are 3 to 4 formulas which you need to remember. And once you remember these formulae, I'll teach you the advanced usage of these identities. Okay, so the first double angle formula is sine 2 theta, okay, which is basically equal to 2 sine theta into cos theta. Okay, this is basically the first double angle formula, correct? Now, the second double angle formula, okay, so there are actually 2 formulas here for cos 2 theta. Okay, so the first formula is 1 minus 2 sine square theta. Okay, cos 2 theta equals to 1 minus 2 sine square theta. And yeah, you already know that sine square theta is basically just equal to sine theta the whole square. Correct? This is what you know. Now, okay, cos 2 theta is another formula, okay, which is basically equal to 2 cos square theta minus 1. Okay, so these are basically the 2 formulas. Okay, and yeah, cos square theta and cos theta the whole square is the same thing. Okay, so yeah, basically both these formulas work, okay, while you are solving a past paper problem. Okay, but sometimes you need to read the situation properly, you need to understand the question and then use one of these formulas appropriately, okay, for cos 2 theta. Okay, so now the third identity, which is basically tan 2 theta, okay, which is equal to 2 tan theta, which is simply divided by 1 minus tan square theta. Correct? So the sine, cos and the tan double angle formulas are really important to remember. To implement these, you need to solve a lot of topic wise past paper examples and other past paper examples which we'll be doing in the video also later. I've named it as the past paper examples for trigo identities. Okay, but yeah, you need to remember these formulas by heart. I know it's given in the formula booklet, okay, but it's better to remember it so that you know how to implement them. Got it? So now basically we'll be doing the advanced usage of these identities. Okay, so the advanced usage you need to know are is used in this chapter of trigonometry and even used in other chapters like differentiation or integration, which we'll be doing later. Okay, so this is really important to know. Okay, so let's do the advanced usage. Okay, so basically the advanced usage is nothing, it's basic conversion. Okay, so you need to know, I know that sine 2 theta, okay, is 2 sine theta cos theta. Okay, what if I give you something like sine 4 theta, correct? Then basically my formula becomes 2 sine 2 theta into cos 2 theta, correct? You need to understand this conversion. Okay, so if you see here, when I had 2 theta here, correct, I only had theta and theta. But now this 2 theta here has become double, it has become 4 theta, correct? So even the theta and theta here will become the double, which is basically 2 theta, correct? This is what you need to know. In the same way, if I write something like sine theta, okay, this can be equal to 2 sine half theta, okay, into cos half theta. Okay, you need to know this. How is this written like this? Because here, when I had 2 theta, I get theta and theta, correct? But I only have a theta here, which is the half of 2 theta. So if 2 theta becomes half, then even theta and theta becomes half, which is converted to half theta. Correct? So you basically need to understand this. Okay, this is not only used in this chapter, it's even used in differentiation. It's mainly even used in integration. So it's very important to understand these conversions. So what if I give you something like sine 6 theta? Okay, what can I write this as? Okay, you can pause the video and try. If not, I can explain it to you. Basically, I know that sine 2 theta, it can be written as 2 sine theta cos theta. Correct? This is what I can write it as. So that means I need to know that sine 6 theta is basically 2 theta multiplied by 3. Correct? And if 2 theta here is multiplied by 3, then theta and theta will be multiplied by 3. So I can write this basically as 2 sine 3 theta into cos 3 theta. Correct? So basically you need to know these conversions. It's really important. We can use this for cos also. What if I give you something like cos 4 theta? Correct? I know that cos 2 theta here. Sorry, I'm scrolling up and down because it's really important to know. I know that I have cos 2 theta, which is basically 1 minus 2 sine square theta. So when I had 2 theta here, I had only theta here. Now this 2 theta is becoming a 4 theta, if you notice here. Correct? So if this here becomes a 4 theta, that means 2 theta is multiplied by 2. So even the theta here will be multiplied by 2. So I can write this as 1 minus 2 sine square 2 theta, which is basically 1 minus 2 sine 2 theta the whole square. Okay, I can write it like that. So I can even write my cos 4 theta as 2 cos square theta, 2 cos square 2 theta minus 1. Correct? Because in the same way, if I had 2 theta here, it got multiplied by 2. So it became 4 theta. So even the theta here gets multiplied by 2 to get 2 theta. Correct? So let's take another example. If I write this as cos theta, I can also write this as 1 minus 2 sine square half theta. Correct? How can I write something like this? Because here I simply have 2 theta, so it becomes half to theta. So even this theta becomes half. Correct? So this is the basic concept you need to know. I'm sure you're getting a hang of this. Okay, in the same way, let's say if I have something like tan 4 theta. Correct? So I can simply write tan 4 theta. So I had 2 theta which got multiplied by 2 to get 4 theta. So even the theta which I have here, okay, I'll write it in the bracket, will get multiplied by 2. So I'll simply get 2 tan 2 theta, which is simply divided by 1 minus tan square 2 theta. Correct? So this is the conversion usage which you need to know. Okay, it's asked sometimes in trigonometry, but it's mainly asked in the other chapters. Okay, and you need to know how to apply these conversions. It's a very, very important concept to know. Okay, so but it's really simple to understand. Okay, once you get the hang of it. Okay, so if you didn't understand, please go over this video over and over again. Okay, and once we do the past paper examples, okay, where I've named it as past paper examples for identities, you'll be more clear and you get a strong grip over this concept. Okay, so yeah, please move on to the next video to learn the concept of ASTC and to revise the radian mode and the degree mode. Okay, so thank you very much for watching.